Welcome back, Cloud Builders. Day 13 is here. Alright, today we are tackling databases. And let's be honest, if you are brand new to tech, the world database sounds pretty boring. But here's the thing, data is literally the lifeblood of everything we do. Every app you use, every game you play, every purchase you make, it all lives in the database somewhere. When you look at AWS, though, it gets confusing fast. You would think they would just give us one AWS database and call it a day. Nope. They have over 15 different database services. Why? Because you wouldn't use a sports car to haul a load of bricks, right? AWS gives you different engines for different type of jobs. Today we are going to cut through all the jargon. By the end of this video, you won't just know what NoSQL or ACID means. You will know exactly which AWS database to pick for your exam scenarios. So let's get into it. Here's the game plan for today. First, we are going to settle the oldest argument in the tech, that is SQL versus NoSQL. What do those weird acronyms actually mean and how do they store your data? Then we will look at Amazon RDS. I'm going to show you the biggest trick question of the Cloud Practitioner exam. It involves two things called multi-agents and read replicas. AWS loves trying to trip you up on them. After that, we will talk about DynamoDB, which is AWS golden child for serverless apps. We will hit a few specialized tools like Redshift and Elasticsearch, and finally we will jump into AWS console to spin up a real database. Stick around to the end because we are doing a live pop quiz today. Okay, let's start with the basics. In the cloud world, you basically have two flavors of databases. One is relational, which we call SQL, and the another one is non-relational, which we call NoSQL. Let's look at relational, that is SQL. Honestly, just picture a massive, super strict Microsoft Excel sheet. It has rows, it has columns. If your users table has columns for first name, last name, and email, and you try to add a user but accidentally type their favorite color instead of an email, the database will literally throw an error and say no. It is incredibly strict. And you will see the word ACID on the exam. ACID is just a fancy acronym that means guaranteed reliability. Think about transferring $100 to a friend and you want an absolute guarantee that $100 leaves your bank account and arrives in there. If your Wi-Fi cuts halfway through, an ACID database cancels the whole thing. No missing money. On AWS, your go-to services here are Amazon RDS and Amazon Aurora. Now what about NoSQL? Toss the spreadsheet out the window. NoSQL databases are all about flexibility and speed. You will hear the term key value. What does that mean? Imagine going to a restaurant and checking your winter coat. The host gives you a ticket with a number 42. That is your key. When you leave, you hand them the key and they hand you your coat. That is the value. The database doesn't care if your coat is a red jacket or a blue sweater or a scarf, anything. It just links a key to a value. And it is incredibly simple and fast. Talking about when to use NoSQL. So when you have a massive scale and you don't want strict rules, think of a gaming leaderboard or an IoT thermometer sending data every second. On AWS, your main NoSQL service is Amazon DynamoDB. Even the platform you are using now is using DynamoDB. Now grab a highlighter because this is the biggest trap on the exam. When you use Amazon RDS, there are two features that sound kind of similar. Multi-AZ and read replicas. Let's start with multiple AZ. This stands for multiple availability zones. Think of it exactly like a backup generator at a hospital. It maintains a synchronous copy of your database in another building. Synchronous simply means that your data saves in both the buildings at the exact same millisecond. But here's the catch, that backup generator does nothing under the normal conditions. It just sits there waiting. If your main database catches on fire, AWS automatically flips the switch to the backup so that your application doesn't go offline. Remember this, multiple AZ is strictly for high availability and disaster recovery. Now read replicas. Imagine your database is a famous author and millions of people are asking them to read their old books. The author gets overwhelmed and so you create asynchronous clones of the author. Asynchronous means there might be a split-second delay in copying the data. But now, those clones can handle all the readers. Your main database is freed up to just write new data. Remember this, read replicas are strictly for read performance. If the AWS asks you how to survive a failure, pick multi-agents. And if they ask how to speed up a database crushed by real traffic, pick read replica. Alright, now let's take a quick look at Amazon Aurora, that is the Ferrari. Aurora is AWS custom built relational database. If RDS is reliable Toyota, Aurora is a Formula 1 race car. It is up to 5 times faster than the standard MySQL. If an exam question asks for the highest performance managed MySQL database, they want you to pick Aurora. Alright, you can read this. And now let's talk about the NoSQL king, that is Amazon DynamoDB. I personally love this service as well. DynamoDB is fully serverless. You don't manage any EC2 instances, you don't install updates, or you don't have to buy hard drives. You just say create table and you are ready to go. Its biggest flex is speed. It gives you single digit millisecond latency. It doesn't matter if you have 10 users or if you are using Netflix handling millions of users on Friday night. It responds in milliseconds. Watch out for these two DynamoDB subtopics: DAX and pricing models. What if milliseconds are too slow for your app? You need microseconds. Then you use DAX, DynamoDB Accelerator. It's an in-memory cache that basically preloads the answer to the common question so that DynamoDB doesn't even have to think. The another one is pricing modes. How do you pay for it? You used provisioned capacity if your traffic is steady and predictable. You tell AWS give me 100 reads per second. We have on-demand capacity as well, and you use on-demand capacity if your app might randomly go viral overnight and you just want to pay per click. AWS has few specialized databases. For the practitioner exam, you really just need to play a matching game with the buzzwords. Amazon Redshift. This is a data warehouse. You don't use this to process a single coffee purchase. You use this to analyze 10 years of coffee purchases across the entire world to see what flavor is trending. It handles petabytes of data. Watch out for the Redshift Spectrum. It's a magic feature that lets you analyze data sitting in an S3 bucket without even loading it into the Redshift first. The next we have Amazon Elasticache. From the name itself, it is clear. This is an in-memory cache. It takes the strain off your main database. The exam might ask you to choose between its two engines, Redis and Memcached. Memcached is super simple and Redis is the advanced one. It supports complex data types and can save its state. The next database service is Amazon Neptune. Think of the Roman god of the sea. Neptune is a graph database. It's all about relationships. If an exam question mentions social networks, friends of friends, or fraud detection, it's Neptune. The next one is Amazon DocumentDB. Very simple. If a company uses MongoDB on premise and wants to move to AWS, they use DocumentDB. Okay, let's log this in. Take a screenshot of this cheat sheet. Let's see. Traditional application, SQL application with ACID transactions and complex joins. The service is RDS. Crazy fast enterprise MySQL. What is that? Aurora. We have millisecond latency, serverless, flexible schema, and massive scale. DynamoDB. Analytics and petabytes of history. We use Redshift. Speed up read heavy workloads, reduce database query load. Redis or Memcached caching. Elasticache. Graphing a social network, that is social network graph traversal, fraud detection, relationship queries, that is Neptune. Alright, it's time for our hands-on lab. But before we open the AWS console and start clicking buttons, we need to understand what we are actually building. Think about it. Where does Instagram store your username and password? A database? Where does your Amazon store your order history? That's also a database. So literally everything you interact with on the internet uses a database. Today we are going to build a live MySQL database in AWS. But why use AWS for this? See here. Like in traditional IT world, if you want a database, it was a nightmare. You had to buy physical server, then install a Linux operating system, manually install the SQL software, figure out how to do own daily backups. install security updates at 2 a.m. on the Sunday, and somehow figure out how to add more hard drive space without breaking everything. It took weeks of planning. See, on the right side, we have Amazon RDS. Here comes Amazon RDS, that is Relational Database Service. With RDS, you literally just click create, and AWS handles the operating system, the installation, the backups, and the security patches, and also the hardware. You just get an endpoint, that is a connection string, and you start writing data. It is magical. So let's go build one. Alright, I am here in the AWS console. Simply I will go in the search bar and search for RDS. You can see I will open it, and yeah, now click on this big orange create database button, and yeah, you can select full configuration. So we will be using this full configuration because for learning, for job interviews, and for your cloud practitioner exams, not only cloud practitioner but certification exams, we always use this full configuration. Alright, and now we can see that we have engine options. This is where we pick our database engine. Let's slow down here because this is where most tutorials just say pick MySQL and move on. I want you to actually understand your choices. We have MySQL. This is probably the world's most popular open source database. It is used by WordPress, Shopify, and millions of businesses. So for today's lab, we will select this one only. And we have PostgreSQL. That is, think of it like MySQL smarter cousin. It is more advanced and it has better complex analytics. Also has very heavy enterprise features. Talking about MariaDB, this is the basically community-driven fork of MySQL, and they are incredibly similar. The next we have Oracle, Microsoft SQL Server, IBM DB2. You will see these three massive enterprise giants here. If a huge legacy bank or government agency is migrating to the cloud, they use these. They are incredibly powerful but very expensive. And finally we have Amazon Aurora. This is MySQL compatible as well as PostgreSQL compatible. Aurora deserves a massive spotlight. It isn't completely different coding language. AWS basically took the code for MySQL and PostgreSQL, ripped it apart and rebuilt it specifically for the cloud, so it runs up to the 5 times faster. And if the exam asks you like which is the highest performance managed MySQL database, the answer is always Aurora. For today's lab, make sure MySQL is selected. So for database creation method, we will select full configuration, and then we have templates. There are 3 templates, that production, dev test, and free tier. Production gives you the highest availability, the best performance, and the highest cost as well. The dev test is cheaper with less redundancy, used by programmers to safely test code. And the free tier, yes, it is absolute that it will give you the smallest database designed purely for learning and hands-on experience. So let's click on free tier for now. Watch what happened right below when we clicked free tier. The availability and durability section is now locked to the single AZDB instance. Normally in production, you would choose a multi-AZ deployment. Remember our lesson? Multi-AZ means AWS spins up a second synchronous backup server in another building to save you if the data center goes down. But AWS is generous, not crazy. They aren't going to give you 2 servers running 24/7 for free. So the free tier locks us into the single AZ only. For the engine version, let us use the default, that is MySQL 8.4.8 currently, and move on. Now we have DB instance identifier. By default it says database 1. Don't get confused, this is not the name of your actual database tables. This is just the name of the server holding it. So let's change this to something meaningful like student DB. And then we have credential setting. This is the administrator account for your database, exactly like the root user on the Linux computer. Type in admin as the master name, that is master username, and now AWS asks for credentials manager. This is the cool new feature. Do you want it like managed in AWS Secret Manager or self-managed? Secrets Manager is amazing for big companies because it automatically rotates the password, so hackers can't guess them. But it's cost extra money. Since this is a free lab, select self-managed, uncheck auto-generate password, and type in a secure password yourself. Write this password down because AWS also cannot recover it once you forget it. And the next you can select credential setting as password authentication, okay. And then we have instance configuration. In instance class, notice AWS has selected burstable classes that includes T classes, and it has selected me db t4g.micro for now. This is exactly like the EC2 instance type we learned about it. It dictates how much CPU and the RAM your database gets. A micro instance gives us 2 vCPUs and 1 GB of RAM. And by the way, do you know that the G in T4G stands for Graviton? Graviton is AWS custom super efficient processors. Because we picked free tier, AWS locks us into this micro size, so we don't accidentally run up a massive bill. So for now, storage type, let us select general purpose SSD, that is GP2, and the allocated storage is at 2 GB. Alright, let us keep it default. Now look right below the storage auto scaling. Imagine you write some bad code and your app accidentally creates millions of junk records. Your 20 GB fills up. Without auto scaling, your database will crash. And with auto scaling enabled, AWS says, oh, your hard drive is full, let me automatically buy you more space. Up to that maximum threshold of that, let's say I have kept 1000 GB, so it will scale up to the 1000 GB, so you don't crash. It is an amazing feature for a production company, but for our free tier, it's a trap. If a bug triggers auto scaling, AWS will charge your credit card for that extra space. So uncheck this enable storage auto scaling, and we have connectivity section. For this, see, AWS asks whether to connect to an EC2 compute resource or not connect. For now, we will select do not connect to EC2 instance. This is a wizard feature that automatically links a web server to your database, but we want to understand how our architecture works. So let's keep don't connect checked, and then we have VPC. Also, we have DB subnet group. This is exactly what we learned yesterday in day 12. We will just leave it on our default VPC. Pay extremely close attention to public access. It gives you choice yes or no. So let me know what do you think about it. Should our database ever be directly accessible from the public internet? No? See, hackers run automated bot that scan public IP addresses all day long looking for open databases. Your architecture should always be the internet talks to your web server in a public subnet, and your web server talks to your database in a private subnet. Let me draw this. See, this is your internet and this is your web server, and you have database. So the internet talks to your web server and your web server talks to the database, and this is in the private subnet. The internet should never talk directly to your database, so we must leave this public access as no. For the VPC security group, we just choose existing and leave it on default, and scroll past RDS proxy and certificate authority, leave them as default. They are advanced enterprise features. And under monitoring, AWS offers database insights, keep it on standard. Also expand this additional monitoring setting, and yeah, you can see that make sure this enabled enhanced monitoring is unchecked, so we stay safely inside the free tier. Now at the very bottom you have this additional configuration tab. Expand this and you will see backup. You can choose anything like how much days do you want the retention period, you want to enable automated backup or not. You can choose the backup window as well, like the daily time range in which the RDS takes automatic backup. So with this backup, what AWS does is it takes point in time snapshot of your data every single day without you lifting a finger. Scroll down to maintenance section, you will see enable auto minor version upgrade, it's checked, and this is great because if MySQL releases a tiny security patch, AWS install it automatically for you during the maintenance window. But look at the very last checkbox, enable deletion protection. Make sure this is unchecked. If you check this, AWS literally blocks you from deleting the database. It's a fantastic safety net for a real company, but terrible for our lab, like where we need to clean up resource and stop our billing later. Now I will click on create database. Do not skip or stop the video. Look at the status. It says creating. What is actually happening in the cloud right now? Behind the scenes, AWS is finding a physical server rack, allocating a virtual machine, then attaching a 20 GB SSD hard drive to it, and installing a Linux operating system, downloading MySQL in it, and configuring your admin password as well. Then it set up your network security groups, and it generates a web address for you to connect to. If you did this manually, it would take a whole weekend. AWS does it in 5 to 10 minutes. And we are back. The status now says available. If we click on our database name and look right here under connectivity and security, AWS has given us an endpoint. This long URL string is the exact address you will paste into your application code, so your app knows where to send your data. We have a fully functioning enterprise grade MySQL database server running in the cloud, and we didn't type a single line of installation code. Now, for the absolute most important part of the lab, that is cleanup. See, RDS databases cost real money and they are charged by the hour. Never leave a lab database running. And if you have any older resources like you have EC2 instances created or you have Lambda functions, S3 buckets or anything that is created, you can clean them up. And now we have this action menu at the top. Click on that. You have two options. You can click stop temporary. This stops the server and it stop your hourly billing as well. It is just like turning off your server. AWS will automatically turn it back on after 7 days to perform required maintenance. Since we are totally done with this lab, we will click on delete. It will ask if you want to create a final snapshot. Uncheck that box and type delete me. Okay, and yeah, so let's get rid of it permanently. And just like that, you didn't just blindly build a database. You now actually understand why you selected every single option, from storage auto scaling down to the public access firewalls. Now let's see if this is sticking. I've got 3 real world exam questions for you. Let's break them down. The first question is, your relational database is getting completely overwhelmed by read traffic from an internal reporting tool. It is slowing down normal customer purchases. Which RDS feature should you use? The options are multiple AZs, automated backups, read replicas, or DAX. Think about it. The pain point is read traffic. Multiple AZs is for surviving the crash. So that's wrong. DAX is a catch, but it's only for DynamoDB. And the question says relational database. So the answer is read replicas. The next question we have here is, which AWS service is a petabyte scale data warehouse designed for analytics and business intelligence? We have Amazon Aurora, Amazon Redshift, Amazon Elasticache, and Amazon Neptune. See, here the data warehouse and analytics are the massive trigger words. Aurora is for live transactions. Neptune is for social graphs. The data warehouse is always Amazon Redshift. We have this Elasticache as well. It is fully managed in-memory data store and caching service. So it's built for speed. It's not built for heavy analytics or reporting. The next question we have is, a gaming startup needs a database that guarantees single-digit millisecond latency for millions of players. They need flexible key value data structure. Which service fits best? So we have Amazon RDS, Amazon DynamoDB, Amazon DocumentDB, Amazon S3. Pause here, read the question again and think about it. What should be the answer? S3 is for files, not a database. RDS is relational, so it's not flexible. Key value and millisecond latency points directly to our serverless champion. That is Amazon DynamoDB. So this is the correct answer. Alright, you absolutely crushed it today. Database terminology sounds scary at first, but once you know that key value is just a code check and multi-agent is just a backup generator, it all makes sense. Your homework tonight, go to your practice portal and knock down 10 database questions. Tomorrow is use. Day 14 is milestone 2. We are doing 35 question midterm review covering everything we have learned in week 1 and week 2. So brush up on EC2, S3, networking and today's databases. So brush up for tomorrow's test and keep building. I will see you in day 14.